Dear students, in the previous lecture, that is in the lecture 1, we have discussed about some of the basic concept of the separation process. What is separation process and what is the mass transfer? Also discuss about why the separation process is so important for us for the chemical and petrochemical plants. We have also gone through some basic images and some plants picture, and then we have discussed about the broad categories of the separation processes. What are two different categories, broad categories of separation process? Now in this lecture we are going to discuss about the first thing, that is the basic flow sheet of any separation process. So how the separation process is going on. For example, if this is a separator and the feed stream is going into the separator, what happened? There is a one and very important thing that is required for any separator, and we should know about that thing, and that is called the external agent. It can be energy and can be a material. So with the help of this external agent, this feed stream is basically separated out in the separator, and we can get the different products from the separator. So it means that we need some external agent that can be in the form of energy or that can be in the form of material. So that is required for any separator to separate out the feed stream. So this is a basic flow sheet. Now come to the next topic, that is the different techniques, separation techniques used for the separate out the different materials used in the separator. So there are different types of the separation techniques. One separation technique is by the phase creation. So, and the next one is separation by the phase addition. It can be separation by the barrier. It can be by solid agent. It can be by the force field or gradient. These are the 5 different important separation techniques. Using these techniques, we can develop the separator and we can separate out the different materials. Let us look about all these techniques one by one in brief about. The first one, that is a separation by phase creation or by phase addition. So because this phase creation and phase addition is very close, so we have taken these two methods in a single slide. So this is one of the very common type of the techniques used in the industries, in the plants, where we are using the phase concept. It means that it involves the creation of a second phase. That phase can be a vapor phase, it can be a liquid phase, it can be a solid phase. So we need to create, we need to add a phase in the separator, and that should be immiscible with the feed phase, so that there will be a two phases, and with the help of these two phases we can separate out the materials. This is a basic concept. So how we can do it? So the creation of these phases is possible by by energy transfer. I've already discussed about we need some energy or some material, or from the process, or by the pressure reductions. So these are the techniques how we can create the phase in the separator. So if you look about the flow diagram, simple feed is now sent into the separator where the phase is created, and we can separate these phases, phase 1 and phase 2. These phases are separated very easily. Similarly, if we add one phase in this one, just in the case of this diagram, we are going to add one material that helps to create a phase. So in this way, basically we are adding a one phase. So in this way, separation is also possible. So this is about the phase creation and phase addition. The next technique is, before going to next technique, let us take some example for the phase creation or phase addition. So these are the few examples. For example, flash vaporization, then distillation, then extractive distillation, absorption, stripping, reboiled stripping, azeotropic distillation, liquid extractions, drying. All all are the example of the phase creation. Means in all these separation techniques, we are either creating the phase or we are adding the phase for the separation of the feed material. Now come to the next techniques, that is a separation based on the barriers. So barriers means you have to provide certain barriers so that the separation is possible. In this flow diagram we can see that how there is one barrier here. Because of this barrier, the phases are separated out. One phase is taken out, for example, and second phase is separated after the barrier. So it is a less common techniques as compared to the previous one, but it is a very important one. We can use these techniques for so many very important separation methods. We'll discuss later on. And it uses the barrier which basically restricts or enhance the movement of certain chemical species with respect to the other species. So in this way separation is possible in the barriers. In this one there are membrane separation, that is a one big example for the barriers. Osmosis, dialysis, ultrafiltration, liquid membrane, all these are the example of the separation by the uh, based on the barriers. Now come to the next, separation based on the solid agent. So we are going to give the solid agent. In these techniques, this involves the addition of solid particles which act directly or as inert carriers for the substances so as to cause the separation. Means we have to add some solid particles which directly or are as inert carriers for the other substances. Means it basically taken some materials from the feedstock and it is inert for some other materials. So that's why the separation is possible. And the simple block diagram feed is going into the separator where the solid agents are there, and because of this solid agent some materials are inert with this solid agent, so that will not be absorbed on the solid agent, and that will be separated out, and some material are absorbed on the solid agent that will be separated out after the solid material. For example is adsorption, ion exchange. These are the methods for the chromatography for the solid agents. Now the come to the last one, separation because of the applied fields are the gradient. It's a very simple one. In this technique, the external fields of various types are applied for the separation. For example, centrifugation, thermal diffusion, electrolysis, or in all these one, what is happening? We are creating a force field or gradient to separate out different feedstocks into the different phases or in the different products. So this is all about the separation techniques. Now come to the next topic. This is called the separation factor. So what is separation factor? So very simply tells about the signifies or tells about the extent of separation. Means how much separation is possible for the given system. So the separation factor tells this information. And if you go through a simple mathematical representation of the separation factor, so that representation is given by alpha ij. So alpha ij is basically is simply the ratio of xi1 upon xj1 upon xi2 upon xj2. What is the I1 and 2 and I and j? So these are the basically I and j are the two species, 1 and 2 are the two streams or two phases. So we have a two phases. In a first phase we have to see the ratio of these two streams, means I and j components in the first phase. Then we have to see the ratio of the I and j in the second phase. So this is basically the separation factors. In this way we can calculate the separation factors. And how we can basically conclude this separation factor. For example, if ij is equal to 1, means this value in the phase 1 is equal to phase 2. So it means there is a no distribution. In both the phases same amount of materials are present. So in this condition there is no separation. And if this value is alpha ij is values less than 1, what it means that the stream 1 is concentrated with j and stream 2 is concentrated with the I. And if this alpha value is greater than 1, it means that stream 1 is concentrated with I and stream 2 is concentrated with j. It's a very simple and very understandable things basically you can understand very easily by putting all these values. So this is all about the separation factors. Now come to the next topic, that is the parameters that influences the selection of separator. Now the question is how we can select the techniques for the separation. Which type of techniques are useful for the separation? So what should we have to look for before the selection of the separator? Sorry. So the first one is the feed conditions. We have to know, we have to think about before the selection of the separation processes, we have to think about the feed. Whether feed flow rate is there, what is the feed flow rate, what is the temperature, what is the pressure, what is the feed phase state, and the compositions, particularly the composition of the species to be recovered or to be separated. All these informations in the feed conditions are very necessary before the selection of the separation process. Similarly, the product conditions are also required, means how much purity is required, what should be the temperature of the product, what should be the pressure, and what should be the phase state for the product conditions. So these two, and the next one is property difference that may be exploited, means which type of property can be exploited for the particular separations, mean molecular property you need, or the thermodynamic property, or the transport property, which type of property you need to exploit for the separation. So that is also an important criteria. And then the characteristics of separation operations, means what should be the characteristics, for example ease of scale up, whether that can be scale up is possible. Scale up is means to increase the capacity. Suppose the capacity, we want to double the capacity, so that is possible or not. Sometimes there are some separators that is not possible to scale up, that is not possible to double the capacity of that one, but in the some separation processes scale up is very easy. So we have to think about this one also before selection of the separation process. Ease of staging. Ease of staging means how much easily we can add more stages in the single separator. Stages means more and more purity is required, so we need a more and more stages. So it is easy to add the new stages in that separator. That is also an important criteria. Then obviously the separators temperature, separator pressure, and phase state requirements. This is about the separators, what should be the separator temperature and pressures. Then what are the physical size limitations, energy requirements, environmental limitations. We have to think all these parameters. If for example, if some there are two separators, one is a very energy intensive required, and the second is a very less in type of amount of energy is required. So obviously we have to go for the separators that have the low amount of energy requirements. But sometimes if suppose that separator have a environmental issue, although they have a low energy but environmental issue, so at that condition we have to optimize the situations. So it is not very easy to select the types of the separator processes, separation processes. We have to optimize it, which type of the separator gives the better and the best output for the given conditions. So that's why we have to think about the last, this is the last slide of this lecture, that is the maturity of the separation process, means how much we have developed in the different types of the separation processes, how much research are taking place in particular type of separations, because this is one of the very important thing. If any separation process is a very mature, it means that all the positive and negative points of that separator is known to us. And if any separation process is a very new, so we don't know exactly what are the positive and negative points of that particular separator. So the maturity diagram, this is the maturity diagram, where this is the x-axis that tells about the technological maturity, where the invention started from the technological asymptote, and this is the use maturity, how much it is being used in the industries. So first applications and the use asymptote may. So if you see here, there are so many types of distillation is there, absorption is there, azeotropic distillation, solid extractions, adsorptions with the liquid feed, crystallizations, membrane, technology, chromatography, supercritical. There are basically so many separation processes available here, but if you go through, obviously in the x-axis, more and more higher values are recommended. These are the, suppose if this is the any type of the separator, means these are the, this is more technologically mature as compared to this technology. And if this gas absorption is more mature as compared to the membrane one. So we can say, as far as the technological maturity is concerned, we can say these are the very mature one. Even this distillation, if you look about distillation, it is a very mature technology. And if you are going for the use of the maturity, so obviously they have the very less use these liquid membranes and field induced separators and chromatography. They have very less use. And if you go at higher values, you will see that at the top distillation is at the top. So either you go on the x-axis, that is technological maturity, you will find that a distillation is the highest value, or you can go on the y-axis, that is the use maturity. At the same time, even in the y-axis, distillation is the most mature technology. So by seeing this diagram, we can conclude that distillation is the most mature technology separation process in terms of the use and in terms of the technological development also. That's why we always started any separation process with the distillation. Even in our discussion, we have to first discuss the distillation separator before the any other type of the separation processes. So this is all about the lecture. Thank you very much.